Hello everyone, this is S. Amsa, Assistant Professor, Department of Mathematics from Bharatiyar Arts and Science College for Women. In this session, we are going to discuss about singularity and its types in complex analysis. First, we are going to learn about singular point. What is meant by singular point? A point z0 is said to be singular point of analytic function f of z if f of z is not analytic at the point z0, which means the function f of z will not analytic when you apply the value z0 in the function f of z. Then only we can say that the point z0 is called singular point. Here we have one example, that is, consider the function f of z equal to 1 by z minus 2. When you take the value z equal to for the given function f of z, which gives infinity. So, which implies the function f of z is not analytic at z equal to 2. Therefore, z equal to 2 is a singular point of the given function f of z. Next, we are going to discuss about types of singularities with few examples. First one, isolated singularity, and second one, removable singularity, and third one, essential singularity, and fourth one, pole. First one, we will see about isolated singularity. That is, a function f of z is said to have isolated singularity at any point z0 if f of z exists everywhere except at z0. That is, the function will exist at all points except z0 means we can say that the only point z0 is isolated singular point. Okay, let's see one example here. Consider the function f of z equal to 1 by z minus 1. Here is the solution for the function. That is, first we can differentiate the given function f of z equal to 1 by z minus 1. The given function is in the form of u by v method. So, the differentiated term will be f dash of z equal to minus 1 by z minus 1 the whole square. As z tends to 1, the function f dash of z gets infinity. So, therefore, f dash of z does not exist. Also, f dash of z exists for all points except at z equal to 1. Therefore, z equal to 1 is isolated singularity for f of z. Okay. Secondly, we will discuss about the type removable singularity. If the limit of a function at a point exists and function value is not equal to the limit, then at the point the function has removable singularity. Removable singularity means nothing but when you apply the point z0 in the given function f of z, then the function f of z have no principal part, means then we can say that the point z0 is said to be removable singularity. Okay, what is the principal part? That is, after example for removable singularity, we will discuss about Lorentz series. From that, we will get the principal part. So, here is one example for removable singularity. Let us consider the function f of z equal to sin z by z. Here is the solution for the function, that is, take f of z equal to sin z by z. The expansion for sin z is, already we know that is z minus z cube by 3 factorial plus z power 5 divided by 5 factorial and so on. Therefore, we get f of z equal to z minus z cube by 3 factorial plus z power 5 divided by 5 factorial and so on by z. Next, we split the denominator to each term of the numerator term. Then we get f of z equal to z by z minus z square by 3 factorial plus z power 4 divided by 5 factorial and so on. Cancel out the terms. First z by z, we get 1 is there. In this expression, we have no negative powers of z. So, the principal part are 0 here. Therefore, the z equals 0 is a removable singularity. Next one, Lorentz series. This definition will help you to recognize the different kind of singularities. Let z equal a be isolated singularity of a function f of z. Then by definition, there exists a deleted neighborhood 0 less than mod z minus a, which is less than r, in which f of z is analytic. If z be any points in this neighborhood, then by Lorentz series, that is f of z equal to Summation n varies from 0 to infinity an into z minus a whole power n plus summation n varies from 1 to infinity bn into z minus a whole power minus n. Here the second part is the principal part of the given function f of z, that is we want to have bn value 0. Next one, pole. The type of singularity at any point z0 is a pole if there exists n belongs to n and if limit z tends to z0 f of z into z minus z0 whole power n has non-zero finite value. That is, the limit value of the function f of z into z minus z0 whole power n as z tends to z0 will have non-zero and also finite value. If we have like that of a point, then we say the corresponding point is a pole. Generally, f of z has pole of order n at z0. If the value of n where n equal 1 becomes simple pole. If you give the value for n equal 2, it becomes double pole. Like that, continuing this process, we get like this manner. For example, n equal to 5, it becomes the pole value of order 5. For example, consider the function f of z equal to z square plus 2z plus 3 divided by z minus 1 whole power 5, z not equal 1 at z not equal to 1. Here is the solution for that. Taking limit of f of z on both sides as z tends to 1, we get limit z tends to 1 f of z equal limit z tends to 1 z square plus 2z plus 3 divided by z minus 1 whole power 5 into z minus 1 whole power 5. Here the value z not equal to 1. So we have z minus 1 whole power 5 in the numerator. Then cancel out z minus 1 whole power 5 in both numerator and denominator. Then applying the limit to the remaining expression, we get the value 6, that is not equal 0 and also finite value. Therefore, z equal 1 is a pole of order 5, which means n equal 5. Consider another one example, that is f of z equal to z power 4 plus z square plus 1 by z minus 1 minus I whole power 4 into z minus 3 whole square into z minus 2 minus 2I whole power 1. Here in the denominator there are three factors. Okay, the first one z minus 1 minus I whole power 4. Here the value of z0 is what? 1 plus I. Then the nth value for the first factor is 4. So z equal to 1 plus I is the pole of order 4. Like that in the second factor, here the z0 value is 3. So z equal 3 is the pole value of order 2 because here n is 2. So, and third one is z minus 2 minus 2i. Here z0 value is 2 plus 2i, and then the power of n value is 1. So this z equal 2 plus 2i is pole of order 1. So we can say that is a simple pole. Okay. Last one, essential singularity. The singularity other than removable, pole and branch point is known as essential singularity. When the point z0 is not removable, is not pole, means then we can easily say that the point is essential singular point. Here is an example. Consider the function f of z equal to e power 1 by z. Here is the solution for that. At the value of z equals 0, the function f of z does not exist. The point z equals 0 is neither removable singularity and pole. So it is called essential singularity. I hope you understand in this video. Thank you.